Okay, everyone, hello again. We are on example 5, which again, we are still finding the real and imaginary roots, which should total to the degree when we get done. And we're also going to be writing our answer in factored form, so we get the hang of writing it in factored form and finding the zeros. Okay, so since my highest exponent that I see is a 3, this is a degree 3, which means I should end up with 3 total zeros. So let's see what happens. But before we get there, first we need to factor this thing, which this time I have 1, 2, 3, and 4 terms. Holy hot dog, which means, if we look at our chart, okay, 4 or more terms, the factoring technique we have to use is group factoring. Okay, so we're going to be using group factoring, which remember you guys, when we have 4 terms, the way we do group factoring, we group the first 2 terms together and the last 2 terms together, always, no matter what. So I'm going to group my 3x cubed and my negative x squared together. And guys, this is the problem right here. Ignore like this green stuff and the stuff above it. That's from our previous problem. Okay, so the problem is the 3x to the third minus x squared plus 9x minus 3 equals 0. Okay, so I'm going to group my first 2 terms together and my second 2 terms together. Alright, which remember with group factoring, we have to factor out the GCF of each term. So, let's look at the numbers. So first of all, the numbers, I have a 3 and this one doesn't have 1, so secretly there's a 1 there. So between 3 and 1, okay, I can't really factor anything out other than 1, so that one's done. Okay, but I have an x in each term. So let's think about what's the largest amount of x's I can grab from each term if I grab the same amount. Okay, well this one has 3 and this one has 2, so the largest amount from each term is 2x's, so x squared. Or remember the trick is you pick the lowest exponent, which is a 2. So my GCF is a x squared. So let's see what happens. Alright, I'm going to write my answer in purple that I get. Okay, so there's secretly 1's in front of this, so just keep that in mind. 3 divided by 1 is 3. And x to the third divided by x squared, we subtract the exponent. So 3 minus 2 is x to the first, or just x. Okay, my x squareds will cancel out, and I'm left with negative 1 divided by 1, which is a negative 1. Okay? Alright, then my second term, what is the GCF? So, put my plus sign. Okay, the 9 and the negative 3. Something that goes into 9 and 3 is 3. Okay, and I don't have an x in each term or anything like that, so that's my only GCF. So I'll be dividing each of these by a 3. Alright, 9 divided by 3 is 3, and I don't have anything to divide x to, so it's just x. And negative 3 divided by 3 is negative 1. Okay, and remember you guys, we're supposed to get the same thing in each parenthesis, which I'm going to write this in purple just to keep it consistent. We did it right. I just want my colors to be consistent because I like colors and I like them to coordinate. So, sorry guys, I'm being kind of OCD right now. I'm not OCD that often, but sometimes I am. Okay, so remember you guys, we're supposed to get the same thing in each parenthesis if we did it correctly, which we did. We got 3x minus 1 and 3x minus 1, so yay. So our final answer, you guys, remember in one parenthesis we write the GCFs, in the other parenthesis we write the repeated term. Alright, we're finding 0, so I'm still setting it equal to 0. Alright, my GCFs are the x squared and the 3, so x squared plus 3. And the repeated term is 3x minus 1, so I just dropped that in here. Okay? So again, my x squared and my 3 went in here, and my 3x minus 1's both went in here. So both of these went in here. Okay, so this is factored form, you guys, and you could ask yourself, can I keep factoring? Remember, my highest exponent, if it's a 1, you can't factor, which this one, the highest exponent is a 1. This one I have 2 terms and I'm adding. Now if we look at our chart, when we have 2 terms and we're adding, the only option is the sum of cubes, which means I have to be able to cube root each term, which I can't cube root a x squared and I can't cube root a 3. So I'm done with my factored form. So this, you guys, is factored form. Yay! Alright, now let's start finding our zeros, x-intercept, roots, or solutions. Okay, which remember to do that, we set each of these parentheses equal to 0 because this times this has to equal 0. And if you have things that multiply to 0, at least one of them has to be 0, right? So I'm going to set x squared plus 3 equal to 0 and my 3x minus 1 equal to 0. Alright guys, so I have a quadratic and a binomial. Okay, so that means I can do that little shortcut where I just go ahead and solve. So let's get going. Okay, so to move positive 3 to the other side, I'm going to subtract this on both sides. 3 minus 3 cancels out, turns to 0, and 0 minus 3 becomes negative 3. So I have x squared equals negative 3. Now to undo a square, we got to square root that thing on both sides. Okay, which the square root cancels out the square, so I'm left with x. Remember, whenever you square root both sides, a plus or minus will always pop up. Okay, I have a negative underneath my square root, so to make it a positive square root, an I is going to hop out, and I'm left with root 3. And root 3 is not a perfect square, and it won't break down into anything. Even if I tried, the only thing that 3 breaks down into is 3 and 1. So I don't even have any pairs that can come out of my radical and go on their hot math date. Guys, so these are actually some of my zeros, plus or minus I root 3. So I have two imaginary zeros right here. One of them is positive I, the other one is the negative I root 3. So positive I root 3 and negative I root 3. Alright guys, let's solve this one, then we'll be donezo with this problem. So, I'm going to bring my negative 1 to the other side, which the opposite of negative 1 is positive 1. So I'm going to add 1 on both sides. Negative 1 plus 1 cancels out and turns to 0. 0 plus 1 is 1. So I'm left with 3x equals 1. Alright, to move 3 to the other side, I'm going to divide both sides by 3. 3 divided by 3 cancels out and turns to 1, so I'm left with 1/3. So these are my zeros. Yay! So let's see what we have. Okay, first of all, this is degree 3. Okay, so I should end up with 3 zeros if this is correct. So it's degree 3. Okay, and I have, let's see how many real zeros I have and how many imaginary zeros I have, or imaginary roots. I remember real those are the zeros without the I. So these have I's, so they're not real. I have 1 real and 2 imaginary because I have a positive and a negative, which remember you guys, imaginaries always come in cute little pairs, okay? We have a positive and a negative. Or you can kind of think of them as evil and good and evil twins. They're the same number, one's positive, one's negative. So one's good and one's evil. So I have 2 imaginary. So my total of roots is 3. Okay, when I add them together, I get 3. Okay, which that should equal my degree. So I'm good to go. I got 1 real, 1 imaginary. So awesome job, you guys. I love factoring and I love finding roots. So I hope you guys love it as much as I do.